Also, na,
Yes, ma'am.
that same link is working, so no problem. So now I can see it.
Yes, yes. Okay.
No problem. Started. Also, na,
Yes, ma'am.
no problem. So now I can see it.
Yes, yes. Okay.
Started. Also, na,
Yes, ma'am.
Good afternoon, Mrs. Shetty. I just saw you. I was just into all this organization. Mrs. Shetty, good afternoon.
Vinny, ma'am, our waiting room is on, no?
Yes, also now waiting room is on till now. I was admitting. So now
Oh,
Rachel, I'm admitting. So now I'll stop admitting.
yes, yes.
No, madam has to join. I'll just call her.
Hello, ma'am.
Hello.
Yes,
Vinny, ma'am.
yes, Reason.
Ma'am, it is already 3:47, so I'm posting the link now in group, okay?
Okay, okay.
Yeah.
Reason, madam.
બીજા ફોન માં લઈ લો એમાં આવતું હોય ને તો એમાંથી હું કરી લો કા નહીં નહીં આમાંય ચાલુ રાખ્યું ઓલામાં ચાવ એમજી
Reason, can you hear me? Hello. Father,
Hello.
you will join now for the maths webinar. Reason, madam and father has to join. Reason.
Yes, ma'am. Yes, we lock the meeting at 90. So
Okay.
we'll have that space.
Good afternoon, madam.
Good afternoon. Dr. Jayasree has joined?
Yes, ma'am.
Yeah, okay.
Rizal, I can see 100 participants.
No, ma'am, there are 92.
I can see 100 on my PC. So,
Ma'am,
Father,
that is
Ma'am,
the ones which are also in waiting room. So that
okay.
total number shows there.
Okay, okay. So, Father Blaze said he's just joining. So, just look out for Father, okay?
Yes, yes.
Okay, okay. Rizal, Rizal, can you hear me?
yes, ma'am.
See, Dr. Jayasree just logged out because she had a power cut. So, just let her in. She's in the waiting room, it seems.
Uh, no, ma'am, I can't see her in waiting room.
What to do now?
Has she joined with some other name?
Uh, Let me check her with her. I'll just ask her one second.
Yes, yes, ma'am.
Hello, ma'am, have you joined with some other name? Because we can't see you here in the waiting room. Okay, okay. She's logging in again, Rizal.
Okay, okay, ma'am.
Just check.
Yes, yes.
Rizal,
Yes, yes.
ma'am is getting a
Ethio.
message that
Ethio mathematics.
Vinny ma'am, I couldn't hear you. Can you repeat?
yeah, ma'am is getting a this thing information that meeting has reached the maximum participant and she's not able to join. So what is to be done?
Ma'am, but right now in the meeting we have admitted only 89 participants.
Yeah. So should we remove some participants and then let them join back later?
Okay, but
I'm getting 100 here on my this thing because I think it
I
includes
think
the.
we should remove the participants in the waiting room. Because of that, maybe ma'am is not able to join the waiting room also.
Okay, so
Just tell ma'am that we are removing right now. So just tell ma'am to log in again at the same time.
okay, okay. Hello. So they are removing some participants. So can you please join? Diesel, I can see ma'am there, so I'm admitting her.
yes, yes, ma'am, I admitted already.
Okay, okay. Jayasree ma'am, are you in?
Hello, I'm Jayasree here.
Yes, yes. Okay, ma'am, we can hear you.
Yeah, okay. Yeah.
So what's the time now? So let's begin now. Alsona, can we begin?
Yes, ma'am. It's 4.
Okay, so
Yeah.
Father Blaze is there, reason?
Yeah, I think so. Father Blaise is there. I can see his name.
Okay, okay.
Hello, Father.
Father is there. Okay, so we will begin now. I can't see his name, but
Name. So maybe.
Okay. So good evening, Madam Dr. Susama Samuel, our principal, our resource person for today, Dr. Jayasree Subramaniam, our student coordinators for today, Alsona, we have Clarice, Daya, Rizal, Rachel, and Nisha. So we welcome everyone and the participants, most important, who have spared their time for today's webinar. I would like to start this webinar by inviting our principal to say a few words. So Dr. Susama Samuel, over to you.
Yeah. Thank you, Dr. Vinny. I think you are able to hear me.
Yes, ma'am.
Yes. Okay. So good afternoon, all. Good afternoon, Father. I think so.
Not yet.
Father, yeah. Okay. So, on behalf of St. Xavier's Institute of Education, I welcome all participants to this webinar. With this webinar series on strategies and solutions for mathematics learning, conducted by mathematics unit of our institution, um, guided by Dr. Vinny Sebastian, Associate Professor, University of Mumbai. And also, I think there are 7 students also from the mathematics pedagogy. So I welcome all students and all participants to this webinar. A little history about this webinar, and this is the 6th series of this webinar, and the purpose of this webinar series is to share mathematical research findings, innovations in mathematics with the students and the parents and teachers of school and colleges. And some of the past few of the past sessions dealt with the innovative pedagogies of mathematics teaching. And overall, I can say that the objective of this webinar is to improve mathematics learning and improve the quality of mathematics teaching. The last session, the topic was, or it dealt with discovering aesthetics in mathematics. uh, as the word says, it was a very beautiful presentation, and resource person Dr. Deshmukh brought in many mathematical examples from which I can say that from the nature, from the flowers, from the fruits, from the art form, and in ornaments, etc., etc. And today's topic is also something similar. I don't know my understanding. Only I'm just sharing with you all. Like, is something similar to that area when I looked upon the title. So I was thinking that it is also something similar to that area, ethnomathematics. In
Yeah.
education, actually, yeah, we use, madam, we use the word ethnography in qualitative research, actually,
Hmm.
where the researcher observe and study the real life of the pupil, their identity, culture, etc. So, ethnomathematics may be somewhat a new term for us, and maybe the study of mathematics through culture, or bringing examples in the classroom from the culture or the life of the students. So I was thinking that a country like India, we have a rich culture and a diverse culture. And also we know that multiculturalism exists in the classroom. The teachers can use a variety of examples from the different the cultures of the students to teach mathematics. But there are also I feel there are also challenges for a teacher, because the knowledge of the culture of each student is very important. Not only the superficial knowledge, but I think deep knowledge of the culture is important. So that knowledge is important for a teacher, and also teacher should have skill and plan out the activities in the class to connect this to the students' cultures with the teaching of or learning of mathematics. And now we have seen that the world is shrinking, and there is a global community in the classroom. The culture is influenced by other cultures. It gets diluted, and for a teacher, providing examples from culture is also a challenge, I suppose. So these are only my thoughts when I looked at the topic. And I was thinking that the common things now, which we can share in the classroom, is something like music, or something like cricket, or something which all students are familiar with, or we can use such type of examples in the classroom. So whether my thoughts are in proper direction, I don't know. But anyhow, ma'am is there, Dr. Jayasree ma'am is there. So today's resource person, Dr. Jayasree ma'am she is interested in ethnography, means that she is interested in people, she is interested in culture, she is interested in the identity of the people, and also she is interested in mathematics, and she is the right person to talk to us on this topic. So I welcome Dr. Jayasree ma'am to this session, and also I welcome all participants, and I welcome our manager Father Blaise and my colleagues and our student participants, and also parents to this session. And now the parents are also very important, because the parents are also attending the sessions, and they are very important stakeholders now, because they are at home, and they usually now they listen to all our these webinars and seminars and all. So I welcome the parents are also to this session, and all the best to Dr. Winnie Sebastian and her team of 7 students. You can see the students names and photos on the screen. I have seen that from the last month's webinar series onwards, I have seen that Dr. Winnie and the team is doing a small research also. That is a need-based research they are doing based on mathematics. So that is also a very good initiative, and I appreciate it, Winnie and the team of students. Good initiative. So all the best to Dr. Winnie and all the best to Dr. Jayasree ma'am and all the participants. Over to Winnie. Thank you very much.
Thank you, ma'am, for your encouraging words. I would just like to take you all to a journey of how the webinar series went for these months. Just give me 1 minute. And we started our mathematics webinar series in the month of June. This is, can you all see my screen also now?
Yes,
Yes,
Winnie.
Okay, so it was a real gift to the college as well as mathematics pedagogy unit, and it was a challenging task for all of us. So the main theme we decided as strategies and solutions for boosting mathematics learning. And in the series 1 in June, we had these topics. We had a 2-day webinar on that day. That first series was a 2-day webinar on 29th and 30th of June, and we had all eminent resource persons all the time. So I'm just going to take you through the different topics we had for the different webinars. So this is series 1. We had series 2. Again, we had nice topics, constructivist and enrichment activities for professional development. We had series 3. This is series 4. We had and we had the last one just got over, that is series 5. Okay, so and we have series 6 today, which you're going to witness. So that is our journey from June to November. And these were the different small studies which were done on these different topics: mathematics, teaching, learning during pandemic, mathematics phobia. Today we will have the presentation of mathematics literacy, and we had just launched this study last time. So these are the different studies which were done, and our student coordinators who helped us for the whole webinar series. And definitely we thank all the participants for their support and participation. And we continue to urge you to send a 1-minute video of your innovation. And we have our YouTube channel, Mathematics Learning. So I would encourage you to visit our YouTube channel in case you have missed any of the webinar series. So thank you for your participation, and this was our journey. Now over to Reason now for the introduction of the resource person, Dr. Jayasree Subramaniam. Reason.
Yes, ma'am. Thank you. Good evening, everyone. Today, we are privileged to have with us Dr. Jayasree Subramaniam to speak on ethnomathematics. Ma'am has completed her PhD in mathematics from University of Hyderabad, and she has keen interest in gender, caste, and equity issues. After her PhD, Ma'am carried out an empirical study to understand how gender plays a role in shaping the careers of scientists in premier research institutions of India. In the year 2005, Ma'am joined Eklavya Foundation at Bhopal and started working in the area of mathematics education. Ma'am was a faculty member in the School of Education at Tata Institute of Social Science, Hyderabad, where she taught several courses, including a very popular course called Mathematics Appreciation for BA Social Science students who fear or dislike mathematics. Presently, Ma'am is an associate professor in the Department of Mathematics at SRM University, Andhra Pradesh. Ma'am is concerned about the status of mathematics education in India and believes that the country has to invest in quality research in mathematics education in order to improve its quality. In a small way, Ma'am has also contributed to this by hosting the 10th Mathematics Education and Society Conference at Hyderabad in the year 2019. Ma'am, we are delighted and pleased to have you with us this evening. Once again, a warm welcome on behalf of St. Xavier's Institute of Education and a kind request to begin your session. Over to you, ma'am.
Thank you so much. It was a pleasure to hear all of you. Particularly, I was very pleased to hear that you are doing so much work already. You're already carrying out some small research. You've also looked up what ethnomathematics is all about and have some kind of a sense of what it is actually and what it could contribute. And in fact, I really appreciate the suggestion that came from your principal saying that, you know, we probably might be able to, it's a challenge, it's really a major challenge, and that we probably can try and use something that's common to all the students as part of what one could actually bring into the classroom. Very nice. That's really, I mean, I think these are very, very, it's very interesting to actually make those kind of beginnings. I'm going to try and see, so what is ethnomathematics, and why we should be bothered about it, and how we can try and bring it into curriculum. And I would like to say that right at the outset, I would like to say that in this particular talk, I'm going to say that it's not something that one could do just very quickly, very immediately. It's going to be an involved work, and that it would call for the good bit of research, committed research. And I mean, institutions like you who are already committed should probably collaborate with us, and that, to get together, the researchers and the teachers should work together along with the community to create some new knowledge that can actually be useful in the classroom. With that introduction, let me actually, do I have the share screen facility, right? Yeah. Yes. I'll go to the presentation. Okay, so ethnomathematics is the title of the presentation, right? So I'll try and see if I can put it in the, okay. Yeah, so first of all, I want to begin because, I mean, I'd like the session to be a bit of an interactive session. So I'd like to know what kind of ideas that we all have about mathematics. What do you think is mathematics? I'm going to just kind of write down, maybe here with my pen, I can probably write here. I hope. Yeah, if you can say.
Participants can unmute themselves and please answer so that we can have an interactive session.
Ma'am, mathematics starts with counting. When there was a need for counting, mathematics came into existence.
Okay. Okay. Anything else? Fun with numbers. Okay.
Yeah.
Oh, what happened to no? Oh, it went off to the previous. It went off to the second slide. I do not know how it did. How do I go back to the previous slide? Yeah. Okay. Yeah. Why does it go? Oh my God.
Ma'am, can I say one more thing?
Yeah, please do.
Ma'am, mathematics is a tool to solve real world problems. It's a tool.
A tool to solve real world problems. Okay. Okay.
Mathematics deals with a logic.
Okay. 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 Anything else?
Mathematics means carrying out different operations.
Dealing with addition, subtraction, multiplication, division.
Okay.
Okay. Like I'll
It's a
put
way
it
of
here.
life.
Plus minus this, right? I'll add it. Okay. Yeah.
It's a way of life which insists on systematic progression in any
Systematic.
sphere of life.
Systematic.
Logic of shape.
Logic of shape.
Mathematics is a systematic and logical process.
Yeah. So systematical logical process. Okay. Okay. Where do we actually, how do we understand math? Where do we learn this mathematics?
In the nature. By nature.
We learn mathematics from nature. Mathematics is everywhere, hence way of life, problem solving tool. Okay, all about concepts used in daily life. Mathematics is everywhere. Mathematics is a study of numbers, measurement. So I'm reading out from what some more people have written here. Study of numbers, measurement, operations, and calculations. Okay. Okay. So yeah. Now the thing
mathematics. Mathematics is something from philosophy field. I'm saying, which made Descartes very envious of it. That mathematics is a very accurate science. It's something which is very solid.
I'm going to put that down. This is like what you are saying is. Oh God, why does it go back?
Yeah, because Descartes was always envious of maths, and he wanted to make philosophy as good as mathematics.
Mathematics, right? Yeah. Okay. I don't know why.
Ma'am, there are some responses on YouTube.
Yeah.
Can you hear me?
Just tell me.
So some have written science of number and space. That math is related to day-to-day life.
Science of number and space. Yeah. Okay. Very good.
Then mathematics and nature, studying different theorems.
Okay.
Then some have written logic of shapes, quantity, arrangement.
Right. All right. Pattern, logic. These are kind of, so how do we, where did we get to know these things? How did we know that? How do we know that this is what is mathematics? That's my second question. I'm going to write. So you said this is what, you all had something to say about what is mathematics. Now I want to know, how did you know this? Where did you find out?
Ma'am, the daily needs of mankind. The daily needs of mankind.
Okay. So is that where you found out this is what is mathematics? Is that how?
I mean, maths is used in, so many things like purchasing anything,
right?
Measuring something like.
Maintain record.
Yeah, okay. I mean, I understand, but my question is, how did you know that this is what is mathematics?
Ma'am, this was
formal education.
We learned it in school.
Hey, wait a minute. I think I need to do something. I'll have to disable annotation for others. Okay. All right. Okay. Yeah. Just a minute. Yeah.
It is the building.
So this is so one answer was quite interesting. Formal education, right? Schooling.
Yes.
Schooling is one source of information.
Yeah, it's the main source of information actually.
Main source of information. That in fact is the case. I think that's what I also thought. That we learn what is mathematics from going to school, right?
Yes. Yeah, we started right from the childhood. We started from someone said it started with counting, right?
Right.
And each and every sphere of life we use the measurement, everything going on. But while we only when we introduce the child to a formal education, so they will be learning it quite what to say in a systematic way, right from counting, then going for step numbers, then moving to operations.
Yeah, right. Okay. So essentially our ideas about what is mathematics comes from school, right? Schooling. Most of you, most people actually drop mathematics after school. In India, only 25% of the children of college going age, youth of college going age actually access higher education, right? So 75% don't, but they have probably, many of them, maybe about nearly three-fourths of them probably were in school, most of them. They have been through education, they have had some experience of mathematics learning. And so irrespective of whether we pursue higher education or not, irrespective of whether we pursue programs, higher education programs which involve mathematics, like for example engineering or mathematics or sciences, economics, other domains which use mathematics. Maybe one pursues literature, maybe one pursues domains that call for sociology or anthropology, which do not really call for psychology, which do not call for much of mathematics, right? Maybe some small amount of tabulations and things like that one might need, right? So even then, one has an experience of mathematics. Large number of people have an experience of mathematics. Even people who went to school, who dropped out of school, have some idea of what is mathematics, because as madam said, mathematics is taught from class 1, right from the beginning. And so from there we make an idea about mathematics, right? Yeah, some more people have written something. I'll just take a look at what it is. Math is a building block. Physics is not complete without mathematics. Yeah. Okay. Right. Good. So this is how we get to know that this is what is mathematics. Our notions about what is mathematics comes from basically from education. Right. Next slide. Now, why doesn't it move? I don't know why it's not moving to the next slide. Okay. Now the thing is that, all right, that's good. I mean, you have said something about mathematics and we have heard that, and I've kept that in mind, and we can go back to the slides and see. But the thing is that I want to ask you about music. What is music? Is Hindustani music music? Is Carnatic music? What about, I mean, I have actually disabled this. I think somebody is able to annotate, right? Is that true, or is it my?
It's not annotation.
It's not. Okay. Okay. So what is music? I mean, is classical music real music? What would you call is real music? Would ghazal qualify as music? Today you have pop, rock, jazz, folk music. Are they all music? Are they all music in the same way? How come my screen is gone? Yeah? Host disable. Okay, you have to enable me because I'm a participant, right? You disable participant screen sharing, so this thing is gone.
Ma'am, please try again.
Okay. Yeah. I have. Yeah. So, so what is music? If you look at what is music, there, I mean, are they all? Is there one music, or music is different? If music is the same thing that everybody, if everything is music in the same way, probably we wouldn't call it by different names, right? I mean, Hindustani music, classical is Hindustani classical music. Carnatic music is different from it in some sense. Maybe one might do some fusion. Maybe one might do some jugalbandi like Bala Murali Krishna and Bhim Sen Joshi used to do very beautifully. But then they're both different, right? I mean, they're both called music and they're both different. Western classical music is there, and that's still different from what we know as music. We may not even appreciate Western classical music. You may appreciate Carnatic music very much, but you may not appreciate. I mean, these are ways to actually say that there's a difference. Just that a person who appreciates one form of music may not appreciate another. People, for example, who appreciate folk music may not necessarily appreciate Carnatic music, and Carnatic musicians may not probably appreciate folk music. And the question is that, are they all equally music, or some music is more musical than the others? Just now, today, for example, I heard some music which is really very different. Tamil music that is now called Ghana music, that's come up. Very interesting. Maybe it's been there for long, but I just heard it today. I was just wondering, like, are all these music same, or is there some hierarchy? Is something more musical than the other? Can somebody say something about it? Yeah, let's see if there is. I mean, you can say also so that I can. All are same, is it? Okay. All music form is treated equally. I mean, do we actually treat all music form?
Ma'am, as for Indian music, it is based on ragas, but I don't know about Western classical.
What about the Indian folk music, in Indian Ghana music, Indian pop, indie pop?
Ma'am, basic sense of all the music are same. Then evolution of music is different in different genres.
But for example, you know, very recently this very famous musician died. You know, S.P. Subramaniam.
Yes.
He constantly, all his life, he said that he did not learn music, and in fact,
because music is in nature.
It's no. What I'm saying is that he was one of the famous, very well-known singers, right? But still, he thought that he didn't learn music, but he could sing very well. And he said that he didn't learn. He doesn't know music. He has not learned it. Now, most of the people who are probably singing in film music have not learned classical. You said that all music is got the seven swaras or whatever you said something sometime back. Right, but some people have not learned that. They're still singing. Should we call that music or not?
Ma'am, actually, even if you don't consider whether they are made up of 7 notes, they are made up of the 7 notes.
They are made up of 7 notes.
If we study the science of it, we have to accept the fact that they are made up of 7 notes and they are based on ragas.
We can. I mean, those of you who actually know math, I don't know music. Those of you who know music may actually be able to decode it and fit it within the seven note scheme and explain it. Is that what you're saying? Yeah.
Yes.
Okay. All right. So, in some sense, what you're saying is that all music, Western music, Eastern music, classical, Hindustani, ghazal, everything is made of just those 7 notes. And that give me a music, I will decode it and say. That's what you're saying. Is that correct?
Yes,
Western music, you will be able to decode it.
Yes,
right?
Yes.
Yeah, everything. That's fascinating, very interesting. Okay. Yes. So the thing is that there's also hierarchy. There's also high and low in music. That cannot be that. I mean, the very fact that film music, people who have not learned music systematically are able to sing film music, but very rarely they are able to allow to sing Carnatic or Hindustani. Shows that there's some kind of a hierarchy. There's some kind of a hierarchy there. Some music is considered more, I mean, not very easily reachable by ordinary people, right?
Yes, ma'am. Yes.
But and people sing. Almost everyone sings, right? Somewhere or the other, right?
Yes.
Yeah. Right. Okay. So here I'm going to go to ask one more question. Next slide. How does this move? Why doesn't it? Why am I not able to? I don't know. This I think I'd probably escape from the. I don't know why this is not moving. When I did not want it to move to the next slide, it kept moving.
If you click on the slide, then down you will get arrows. On bottom left, you get arrows.
Okay. Right. Okay. Yeah. Right. Okay. So again, the same question comes to literature also. Right. I'm from Tamil Nadu. I say Ramayanam, Mahabharatam, Silappatikaram. We consider these as literature. There's lot we have huge amount of literature. Then there's literature up to today. New literature is being created. Those of you who studied English literature would have studied Shakespeare. I know somebody who holds Shakespeare as the ultimate person in English literature. I mean, like everything seems to be available for that person within Shakespeare. Everything from the past, present, future, everything the person can read from Shakespeare. Then there are others. Now, then people talk about literary quality. And there are also a whole lot of new genres that have come into literature. So for example, in India, you have women's literature. Women have not been actually writing for long. Then women started writing. Is women's writing actually literature or not? That was a question at some point of time. Now there are also a whole lot of other regional writing that's there. And there's also Commonwealth literature, Commonwealth literature referring to certain regions, certain location. So in all these things, I mean, I'm asking some kind of a question which actually is linked. So the thing that I'm asking is that we as people most of us who are actually educated, right? We are the ones who are actually into this whole questioning of trying to understand what, we are the ones who are actually talking about it. I mean, at least we only know of us talking about it. Our interaction, my interaction on these matters with people who have not had the opportunity to have education is minimal. So I really do not know what they think about these questions. I'm only talking about us and what we think. We have certain understanding about what is music, what is literature, what is mathematics, and these things we learned by and large as a result of, as a consequence of our education, right? We have, and we also know that there are differences within. And there's a very important question here. The question is, who makes these decisions about what is mathematics, what is music, what is literature, and what is not? Who decides to include and exclude? Who decides these things?
The general public.
General public, you and I can decide what is literature. I mean, like what? You might appreciate some literature, like, right? I might appreciate some literature, but do I have the power to actually say that, well, this is, to get others to accept that this is literature?
Might be the subject experts in the particular field.
Experts, right? By and large, it is the experts' decision. So in some sense, there's power there, right? So those who are deemed knowledgeable about a certain domain decide for the rest of us what is literature, what is music, what is, I mean, you might consider the music of some community, which, for example, in Tamil Nadu, there's a community whose only job is to come and play the drums when somebody dies, right? That usually these people don't even, I mean, they're also considered as untouchable side. They are not also included in most other places. Their music is not included in most other places. Now, that music may not necessarily get even recognized as music by the experts, right? So there is actually a question of power that is part and parcel of most of what we do. And mathematics is no exception to that, right? That's where I want to begin. That's where I want to begin this whole discourse on ethnomathematics. Power is very central to any decision making, and the power usually is not, the power doesn't necessarily mean that it is actually bad. Power can be extremely productive also. Power is an expression of the times, and certain things have power at certain point of time. Like, for example, our Ramanujam survived because of certain kind of opportunities that actually worked out at that point of time. The fact that the kind of mathematics that he was doing was considered desirable by a certain set of people who actually paid attention to him and made him the star that he is. Made him the star, meaning giving him the opportunity to express himself, giving him the opportunity to write what he wanted to write, right? That itself, I mean, otherwise he could have died in some little corner somewhere writing all the stuff that he wrote, but we would have never known that here this man actually knows something. Even G.H. Hardy, when he looked at his stuff, the only reason why he thought he must be knowing something is that if somebody did not know what he was saying, he couldn't have written the kind of stuff that he is writing. He wasn't sure whether what, because Ramanujam hardly ever gave proofs of most of the things that he said. He probably did not have a very he was not rigorously trained in mathematics in Western mathematics, right? That doesn't mean that he belongs to the Indian tradition. He actually is somehow, he created mathematics. He was a creative mathematician who was not really properly trained, formally trained, who had no notion of writing proofs for most of the things. And the statements that he wrote were so esoteric that Hardy thought that if one did not really know what one was saying, one wouldn't be able to write something like this. So he gave him a chance, right? So it's a time space that actually allowed a genius to be recognized. A genius might exist, right? Genius may go unrecognized. So Ramanujam was lucky in that sense of the time, and that the thing is that you must look at the time and the space. So now, if you come to mathematics, is there only one kind of mathematics? Or are there many different kinds of mathematics? We looked at examples of music and literature, right? There are different kinds of music. They do not belong together. Pop music and Carnatic music do not really sit together. They are probably recognized as music, but they do not really sit together, belong together as one same whole. They are two different kinds. They go by different names. What about mathematics? Is mathematics unique? Have all cultures, in fact, nature and people, have we all done the same mathematics? Do we all do the same mathematics? Is there only one mathematics? Is there some answers? Some are people's? Certainly not. There are several kinds of mathematics. Yes, arithmetic, algebra, geometry. There's yeah, that's right. That's all part of mathematics. That they are not considered as. There are different branches of mathematics, but mathematics is universal, is what somebody is saying. But Pragya Patnaik says that certainly not. Meaning, like there are different kinds of mathematics. Is it? There are different schools of thought, fundamentally different. I would like to know that. It's a. Would you like to elaborate on that?
Yes, ma'am. I mean, mathematics, as like for us who are students or teachers of mathematics, the way we see mathematics compared to, say, a shopkeeper or a small businessman, how they see mathematics. So it's fundamentally different. You know, for us, mathematics is more of a science, and for them, it is like everyday life.
And they're not the same.
They are to some extent same, but then again different.
What is the difference? I mean, it's very interesting, particularly given that you are actually speaking from the School of Education. I'm keen to know a little bit more about what you think is the difference.
Okay, we have two types, namely, we say it is pure mathematics and applied mathematics. The pure mathematics, in the sense which we learn in the very formal way. Mainly, we are concerned with the theorems and the proofs, etc. So, we're coming to applied mathematics, which we apply in the engineering, and even in the artificial intelligence, whatever it is going to be totally the application part.
But I want to go back to also what Pragya Patnaik madam said. Please, ma'am, you continue with what you wanted to say.
No, I mean something similar. Like I'm a teacher.
You said that there is a difference.
Basically.
I wanted to understand about the difference.
Yeah. See, for example, I'm a teacher of physics, right? So when I use mathematics in my classroom, the way I use mathematics in my classroom, and as I said, some other person, like a friend of mine who is a housewife, she also uses mathematics every day in her life. But her use of mathematics and my use of mathematics, we can say basically is the same thing, but the way we are using, both of us, are me myself in my house and me myself in the classroom, how I am using
mathematics. Right. Now I use probably sometimes, I mean, I carry a mug, I carry this cup, my tea cup. I sometimes can just put some glass of, I put a glass of water sometime. Most of the time I have coffee or tea in this.
Yeah.
It's a container, right? I use it for different purposes. Suddenly I have to water my plant and I just take a glass of water in this only and water the plant also.
Yes.
So that means the container has not changed. The purpose for which I'm using it is changed. So I mean, that's not what you want to say. I mean, then it is the same thing. Now the container is.
You asked kinds of mathematics. I said there are different kinds of mathematics. How we are, I mean, I can differentiate on the basis of how we are using mathematics as different kinds of mathematics. We all learn mathematics as counting, numbers, arithmetic. In primary school, we all learned through that thing only mathematics. The basic learning for all of us is same in mathematics. Then as we grow up, I guess how we see it is different.
Yeah. So again, what Geeta madam said was also pretty interesting, that she said something about pure mathematics and applied mathematics. So in fact, I want to look at what, I mean, I'm a pure mathematician in that sense of the term. When I did my PhD thesis, I worked on something really what is called pure. Basically, what do pure mathematicians do? They answer. I did not answer any of these questions. They ask questions like this: can every number be written as a sum of two prime numbers? Does the equation x to the n plus y to the n is equal to z to the n have non-trivial integer solutions? Non-negative integer solution. Do we need more than 4 colors to color an arbitrary map in such a way that two regions sharing a border do not get the same color? Do you know that? Do you know of these questions that I'm asking? Do you know of these questions that I'm asking? These are all really big questions. This second question It's called the Fermat's last theorem. This was recently proved. In 1993, it was proved. It was waiting unanswered for 300 years, right? This one, last one, is called the four-color theorem. Okay, the proof of this was actually is still something that has, I mean, it's been a very, very difficult, challenging problem. Finally proved sometime in 1980s. It was proved that you do not need more than 4 colors to color any map anywhere. And then this is an open question. It's not yet been answered. Can every even number be written as a sum of 2 prime numbers? That, I mean, obviously the question remains, because all the prime all the even numbers that you can, so far whatever you have tried out, you have been able to somehow write it as a sum of 2 prime numbers, but we have not been able to provide a proof. Right? These are the kind of questions that mathematicians ask. Now, what is the point in asking these questions? Why are mathematicians interested in these questions? What does one get out of it?
Ma'am, so that we extend the frontiers of mathematics, of the subject, for the sake of the subject.
What does that mean?
Like I could solve some problem which would involve the answers to these questions.
We don't really know what use Fermat's last theorem is in real life, or anywhere really. I mean, how this question of, like every even number, can it written as sum of 2 prime numbers? In what way it's going to be useful? I mean, and what's the problem? If 4 colors are not sufficient, you use 5 colors. Why are we interested in 4 colors? What's so great about having only 4 colors? I mean, you want to color a map, which is something that all of us did when we were in school, right? You just needed to take 1 more color, right? Why do we worry about if 4 colors are sufficient or not? And a huge theorem has been solved, and then the theorem is, I mean, it's a famous theorem. 4-color theorem it's a famous theorem. You have a Wikipedia page on that. And this is one of the most fascinating theorems. And you must note that all the things that I have written are actually some examples of mathematics that actually can be written in a language that is understandable to common people. Otherwise, some zeta function, eta function, blah, blah, something, some affine variety, etc. We use terminologies that are absolutely, I worked on something called p-adic numbers, and I looked at something called some representations, admissible representations. I mean, nobody will understand what I actually worked on, right? But the thing is, I mean, luckily there are at least a few statements that we are able to make that everybody can, I mean, a school-going child can actually understand these statements. All these statements can be understood by anybody, almost anyone. Even, I mean, this question, the 4-color problem can be given to anybody. Even if you have not gone to school, you can actually consider this problem. I mean, you can try to actually try and see whether actually you can 4 colors are sufficient, or whether you really need, you can actually produce a map that needs more than 1 color, more than 4 colors, right? Yeah. So, I mean, why are mathematicians interested in these kind of questions? What is mathematics, and why are mathematicians interested in these kind of questions? Is it because it's useful? This is one kind of mathematicians. They are interested in it. For them, they kind of, I mean, I am allergic. If somebody tells me pi is 22/7, I feel allergic. I feel no. The first question I ask is, okay, can you give me an example of a number that's both rational and irrational? I know. I'll go to the class and ask, okay, can you give me an example of a number that's both rational and irrational? Students will say, yes, madam. I say, okay, what? So pi. Why? Because pi is 22/7. I said, no, pi is not 22/7. Pi is approximately 22.
Approximately 22/7.
Yes. See, for me, that's very important. Pi is not 22/7. Right? For an engineer, it's not a problem. For a physicist, it's not a problem. For me, it's a problem. You can't say that pi is 22/7. You have to say that pi is approximately equal to 22/7. If you forget the approximately, I will actually catch you and say that, no, see, 22/7 is a rational number, pi is an irrational number.
Yes, ma'am, yes.
Right? All these things all these fuss I will make. Right? Now, what is it that mathematicians are interested in? What are they studying? And in what way are they studying?
They are very accurate about what they are speaking. They are very precise about what the words that they use.
And why are they doing this?
To perfect the body of knowledge.
And for what end?
so that everything is defined properly?
So, the thing is that the actual thing is that mathematical knowledge, mathematicians are basically studying number and space and other mathematical objects like topological spaces, affine varieties, whatever. I mean, like, I looked at something like periodic numbers. They are looking at certain objects, what kind of objects are they? How are they related to the real world? Are we actually addressing, is the object of a pure mathematician addressing any of the real world issues? The thing is that no, it is not. They are actually, their concern is trying to establish mathematical truths, right? That's what they're interested in. So one of the major problems, what goes as mathematics today in the universities, in all the universities all over the world, that mathematics that we talk about as mathematics has an axiomatic basis. It's kind of, now it is universal. Nowhere in the world people can actually do something else. Every university across the world, actually they talk the same kind of mathematics. Now you might ask what other kind could be there. We will come to that question. Please mark it and ask me. If I forget to address this, please ask me this question, because it's very important to answer that. So we learn similar kind of stuff almost all over the world, and this kind of mathematics is axiomatic in nature, and it actually, the end of this mathematics is actually finding truth, right? You are interested in establishing mathematical truths. G.H. Hardy, a famous mathematician, said that, see, we don't study mathematics because it is useful. We study mathematics because it is beautiful. We actually see beauty in mathematics, aesthetic values that mathematics use, not the application. We say, okay, somebody may apply. I'll come to a quote of his, right? Now, on the other hand, here is the thing which I can go to the next page. Yeah. So the one kind of mathematician, the pure kind, are the ones who are interested in exact knowledge. I mean, this statement, actually, this word came from somebody. One of you said exact knowledge. I was quite pleased. Yeah, this exact knowledge about what? About numbers, geometrical objects, and other mathematical objects that one can think of. They are not at all worried about application. Hardy says this. We have concluded that trivial mathematics, the trivial mathematics is, on the whole, useful, and that the real mathematics on the whole is not. And he obviously wants to pursue real mathematics, right? Not trivial mathematics. So for him, well, yeah, if you can, I mean, we are not bothered about application of mathematics. We don't care, right? We don't really think about application. We are pursuing mathematics as an end in itself. We want to know the mathematical truth. It's actually extremely important for me to know whether a certain even number can be written as a sum of two prime numbers or not. Right? That's what I'm bothered about. Again, actually, and people can kill themselves over. Fermat's last theorem has a history of a whole lot of men who killed themselves because they could not. I mean, they thought that what the hell, what's the point in living if I cannot solve something like Fermat's last theorem, right? And that problem remained open for 300 years. And at the end of the 20th century, it used the most sophisticated mathematics that has been developed till then to finally find a solution for a problem that was written 300 years back by a lawyer who wrote in the said that I have a truly marvelous proof which the margin of this book is too small to contain, right? 300 years of torture to solve a problem which we are saying, Hardy says that we are not interested in whether it's useful or not. We are interested in just mathematics as for its own sake, as one of you said. We are interested in solving mathematical, answering questions in mathematics because this is a pursuit of truth, not application. Now, that's one kind of mathematicians, and these are the people who are actually called mathematicians, right? They are called the academic mathematicians, the people who are actually called real mathematicians, real mathematicians, pure mathematicians, right? The impure mathematicians, what do they do? There's no impure mathematics, I'm just joking. Yeah. Okay, so there are some more comments. I'll go back to this thing. Okay, so now the real world we live in uses a lot of mathematics. Physicists, statisticians, probabilists, engineers, computer scientists, economists, accountants, financiers, even biologists seem to need a lot of mathematics now. Everywhere people are using mathematics. But they use mathematics which is different from the kind of mathematics. They do not actually, I'm teaching mathematics for engineers now. I'm teaching linear algebra for engineers. Their understanding of mathematics and my understanding of mathematics is so different. They have a very different approach to things. For them, approximations are fine. So I tell them, okay, now solve these linear equations and you get these solutions, check, put it there, check whether they're actually solving the equation. Now what they do is they commit a mistake, they get a slightly wrong answer, but then they will substitute and they'll get approximately equal answer. They'll say, yeah, it solves the equation approximately correct. I said, no, I'm not tolerating approximation. I want that these X, Y, and Z should be exactly solved. No, I don't want to say that, okay, it is giving you 7.9, but it's 7.8 or 7.7, and you have to be getting 8, and no, it doesn't work. It has to be 8, and if you give approximately equal, no, I will not agree. Left-hand side is approximately equal. Approximately equal to right-hand side will not work for me. I want exact answer. They don't worry about it. They're approximately equal. Chalega. Their world is like that. They actually in fact, what is most fascinating is that with this approximate mathematics, they design tools. They actually design a spacecraft. They design things which actually fly, which actually reach destinations, which actually deliver things to us, which actually do whole lot of things for us. The physical world is actually the mathematics that is involved to run the physical world, which is so complex today. We're involving so many gadgets that all of us use, including the machine which I'm using to actually communicate with you. These are all designed by non-pure mathematicians, not the pure mathematicians. We don't know. I mean, we pride ourselves in saying that, oh yeah, I mean, I don't use the computer as anything other than a text. I mean, just a text editor. I don't need the computer, right? We do pure mathematics. So the not so pure mathematicians are doing another kind of mathematics with which they are running the world as high powered as they are running it. So there's a different kind of mathematics. It's very important to take this difference in mind, right? This is like classical music and some other music. They are different. Epistemologically, they are different. Epistemologically, these two approaches to mathematics are different. They are not the same. In the university, when you say that two objects are same, if they have to share a same epistemological concern. So applied mathematics or engineering mathematics and pure mathematics do not have the same objectives to achieve. They do not use the same approach. We fuss about so many things. They don't fuss about several things because they will never encounter the kind of difficulties that we encounter because we are stuck within an axiomatic framework. They're not. They actually deal with things that work, right? So we are actually using mathematics, sometimes use the same words also, but they will also use vector spaces. We will also use vector spaces, but we live in very different worlds. We are not doing the same kind of mathematics. That's a point that I want to actually make. And next I want to move on to asking questions about, okay, at least we talked about two different kinds of mathematics, the mathematics that the mathematicians do and the mathematics that others do. Those who are not mathematicians do. Hey, where is the pointer? Yeah. Okay. So what are the kind of mathematics is there? So as madam said, everyday mathematics is there. Street mathematics is there. Street mathematics is what? Street mathematics is what you actually encounter when you meet a vendor. I had a student who did his MA dissertation with me, and he went around interviewing vegetable vendors. He lives at vegetable vendors in Hoshangabad. So one problem that he actually solved was very interesting. There were quite a few problems, but this one thing that I repeat everywhere. So he asked this vegetable vendor to tell him, if you have 500 rupees and share it amongst 3 people, how much will each one get? Can you quickly tell me the answer without using a calculator? Without using any technological tool, can you please tell me the answer for this question?
170, ma'am.
You have 500 rupees, 3 of you share.
Yeah, nearly 170.
170, roughly, approximately, right?
Yes.
Approximately. Why have I come out of this? Yeah. Approximately 170, is it? No, he gave an exact answer. Somebody else will give me an exact answer.
168.
168, exactly?
No, 501 divided by 3 I did.
You did, you were by hand?
No, mentally 501 divided by 3.
Oh, you mentally you did? Mentally?
501 is divisible by 3. That is why.
Yeah, so you did it mentally.
Yeah.
Okay. So he did it very interestingly. He answered this vegetable vendor. He said he actually gave the answer 166 rupees 50 paise. So my student was quite impressed. He said, how did you find? He said, I'll slip into Hindi bit. My Hindi is very bad, but I'll still slip into it and I'll say. So he said, first you give everybody 150 rupees, 3 of them, right? You give 150 rupees to 3 of them. So you have spent 450. You are left with 50 rupees. Give everybody 15 rupees. right? You have spent 45 rupees. You are left with 5 rupees. You give everybody 1 rupee 50 paise, right? So 150 plus 15 plus 1 rupee 50 paise. He did all that in his mind quickly. And then he said, okay, you will be left with 50 paise, for which they get apparently 3 BDs. And so it's equally divided. But 166 rupees 50 paise he got, this illiterate vegetable vendor, in no time. And this is our experience. All of you will agree. When we go to buy vegetables on the road, the street fellows, they all do the computation much faster than we can do actually, right? Right. So there is something called street mathematics. There is this person, Teresina Nunes, who has actually worked with the people on the streets of Brazil to understand the kind of mathematical knowledge that vendors have and the challenges that they face in the school. So she has a very famous book called Street Mathematics and School Mathematics. She's actually a trained psychologist who moved to education, mathematics education, to inquire into this whole phenomenon of saying that our children have learning difficulty. Then what? These children don't have any learning difficulty. They are able to do all these mathematics perfectly. What is the problem? Why are they not doing it in the school? They do it all right when I ask them orally, but they are not able to do it in the class when I ask them to do it using this symbol system that I am giving them. This is a study that she has done. And that's again an important thing to mark. Please note it down, the difference that I have used some very important words here. That orally they did it in the class on the street, and they could not do the same thing in the classroom using symbols. Note it down. It's important for us. So the mathematics, I mean, all this mathematics is something that people did not learn in school. They learned it outside on their own. From whom did they learn? That's something that we need to think about. From whom did they learn is something that we need to seriously think about. Okay. We also have this notion that mathematics, people do mathematics. I mean, everyday mathematics, for example, is something that we do it because it's very useful. But that's not really true. In fact, ordinary people, do a lot of mathematics because it's actually fun. There are a lot of puzzles, games, right? This is called recreational mathematics. This is actually one of my friends actually gave me a problem. He gave which his grandfather gave him apparently. So the problem is like this: mother makes some number of idlis and she has 3 sons and she's going to work in the field. So she's made the idlis and put it in a dabba and told the sons that, hey guys, when you get up, you divide the idlis and eat. Nobody breaks an idli and eat them. We all understand that. 1 idli you will eat. You will not eat half a idli and divide and put half a idli and go, right? Everybody will take 1 full idli. So the first fellow gets up, he divides the number of idlis that are there into 3 equal parts, eats his share, mixes up the remaining and goes off. The second one gets up and he does not know whether the first one has eaten or not. He again divides it into 3 equal parts, eats his share and again mixes the remaining and goes off. Then the third one gets up, he comes, he also does not know whether the other 2 have eaten. So he again divides into 3 equal parts, eats his share and he goes off. Then the mother comes back in the evening and finds that there are still some more idlis left. She again divides it into 3 equal parts and gives it to her 3 sons. So if that is the case, and if she made, obviously she's not just generally, they're really eating idlis. It's not that she did not make any idlis. 0 is an answer for it. But if it is not 0, what is the minimum number of idlis that she could have made so that this was possible? This problem you can answer, so solve it later on and tell me. If anybody already quickly has an answer, you can tell me. But otherwise, don't waste your time trying to solve it now. But this problem he gave me once when we were all sitting together, he gave this problem. Somehow, one of us answered it quickly. And then he said that this problem was given to him by his illiterate grandfather, who's a farmer, and he did not use 4. He actually talked in terms of 10 people. Okay. Basically, it is 3 to the power 4. You see that the division is happening 4 times. So it is 3 to the 4. 3 to the 4 is the answer for this. But he thought in terms of 10 to the 10 or something like that. Or 3 to the 10 or something like that. So this kind of puzzles that people do, they're there in everyday life. You find that people come up with mathematical puzzles and people find joy in that. The thing is that, numbers exist also for us, not only for the mathematicians. Numbers exist and we ask questions about numbers. We observe patterns about numbers little bit, not like how, mathematicians actually do that. We do it in our own way. And we actually, okay, if this number had not been this, but then something else, like sir said just now, if it had not been 500, but 501, I can do something with it. Right? So we actually play around. We, the ordinary people, probably illiterate, we also engage with numbers, not only because they are useful, we also engage with number and space for pleasure. there's actually, let's look at one more example of that. Look at these. Do you think there's mathematics here? These are things that women do in India. I hope some men also do. Is there mathematics here?
Yes, ma'am. Symmetry is there.
Symmetry is there. Symmetry is there in several things. There's a lot of here, we'll mess it up. The number of dots that the person has placed here, if you just increase it by 1, you will mess up the whole thing. Has anyone done this kind of column? This is called column in Tamil Nadu. This is called column in Tamil Nadu, and in the month of in the month of December in Tamil Margari, people will actually decorate in front of the house. There will be these million designs that are there, and then I've done it myself. And it used to be a challenge. You just start do something. Somewhere you might commit one mistake, and the whole thing will go off. So you have once again sweep the whole place and begin from the beginning and do it very carefully. You can't miss one dot over there. And so there is a lot of mathematics. And then you can also go from smaller pattern to bigger pattern. You can do it with fewer number of dots. You can do it with bigger. And so the bigger it is, the more complicated it is. You'll have to pay more attention. Smaller ones can be done a little bit more easily. December Margari. Yeah, that's right. That's right. December month, right? This is Rangoli. This is, I think, done largely in the north. A very complicated design, interesting designs are also there. In all this, symmetry is there. Symmetry is there, definitely. And there's much more mathematics than symmetry also. There's much more mathematics than symmetry also here. There is, for example, here, even though one does not use the term arithmetic progression, actually there is arithmetic progression. When you're going from one smaller this thing to a larger thing, there is an arithmetic progression that you're using. Right? That's also there, but one doesn't use those terminologies there. And the people who do these kind of columns, I have only repeated the columns. I have never created a column myself. But I always wonder who created these complicated columns. Really complicated. I mean, very systematic. I mean, here when you have to count. Okay, you turn here, you do that there. It's pretty. There's a lot of care. I mean, exactness. It's almost like pure mathematics. You have to be pretty exact. You can't really do something approximately, right? That's only then it works, right? It's pretty serious job here, and it is symmetric. Yes, symmetry is what you see at the end of it. Pattern is what you see at the end of it. But there is a lot of exactness that's involved in that process. Yeah, right. And this is again another thing that we do. These are all things that we need not do. Why should we do column? Why did we invent column? We invented column. Somebody invented column, right? And we continue to do it. Why do we need this? Illiterate people. Why do they need it? They are hungry. Probably some of them are very poor also. But then they do this kind of column in front of their house. Why? Because we have a need for it. We have a need. I mean, every one of us want to go beyond our immediate, and we find something pleasing, right? It's not only because it's useful that we do mathematics. Even us, ordinary people, sometimes do mathematics because it is appealing to our aesthetic senses. It's giving us a change. It's giving us a break. It's fun. It's beautiful, right? It's teasing. It teases our mind, some puzzle, right? It's quite interesting. So it's kind of playing with numbers is fine. Yeah, for fun for everyone. So ethnomathematics is going to come in like soon. I'm not yet touched ethnomathematics. So let's sum up with a remark. There are different kinds of mathematics. They are different because they may have similarities, like a tiger and a cat. They have something similar, but they're not the same animal, right? So there are different kinds of mathematics, and they serve different purposes, and they have been created by different kinds of people, and they adopt different approaches. Only thing is that we never have actually been told that there are so many different kinds of mathematics, right? We actually always feel that there is one mathematics, and most of the time we teach children one kind of mathematics in school that at the end of it, they actually hate themselves. They hate themselves, right? Mathematics becomes I mean, I have encountered several students, I've taught mathematics for BA social science students, really brilliant students. Tata Institute of Social Science used to get very bright students for BA social sciences program. But most of them hated mathematics. They will write beautiful essays, but then they hated mathematics. And the moment they see me, they would think, oh God, she's got a PhD in mathematics. She's going to kill me now. So the moment I go to the class and say that, okay, yeah, I'm going to teach you a course in mathematics, their first confusion, we are bad in math, madam. I don't know mathematics. I feel very scared of numbers. The moment I see numbers, I feel this thing. But then most of them enjoyed a course that we did in mathematics, which is called math appreciation, which is very differently designed. And they all said that, if only our school mathematics was like this, we would not have hated mathematics the way we hated it. It wouldn't have frightened us. So the thing that I'm actually saying here is that there are so many dimensions of mathematics that are not brought into school mathematics and made to actually help children actually appreciate and enjoy mathematics in several ways. We say, okay, now find what's 3x squared minus 5x plus 7 is equal to 0. What is x? You commit some mistake somewhere here, there, you do not know, plus or minus, square root, where should I put, why should I put? In fact, one student told me something beautiful. I wrote a polynomial and asked, okay, what is the variable here? 2x squared plus 5x plus 7 is equal to 0. What's the variable here? The student said 2 and 5 and 7 are variables. I said, why? Because ma'am, everywhere you have x coming, only equation to equation, only you change the coefficient. So they are the variables. She said, and that's interesting for me. I'm a teacher, you see. For me, it's very interesting because students have those kind of confusions in their mind. And that we are rushing fast. Now we are teaching them. We are not giving them a moment to enjoy mathematics. And some of them who hate math carry scars in them. So, yeah. Mathematics functions as a gatekeeper. Middle class and upper middle class somehow force their children, okay, you don't understand mathematics, you hate mathematics, just finish the 10th class exam, after that never look at mathematics. Yeah, I don't want to look at mathematics, I want to do journalism, I want to do history, I want to do literature. They pass, most of them pass 10th class mathematics. There are 5 coaches sitting there drilling them and they somehow pass. But a whole lot of children from the margins, when they fail, we ask them, you have finished 10th class? No, madam, 10th class mein fail ho gaya. So what happened? Which subject you failed? Typically, it will be mathematics or it will be mathematics and English for us, right? So mathematics functions as a gatekeeper. So you actually are coming from the margin. You have no resources, no support, nobody to put 5 people who will actually coach you in mathematics, somehow protect you and make you pass so you can drop mathematics. They all say that, well, we didn't want to do mathematics. We just wanted to pass the 10th class exam, but we couldn't. So they continue to. Their parents have been doing menial work for us, earning very little, and they will go back to do the same work. So mathematics actually functions as a gatekeeper, preventing people from certain margins, cultural margins, from breaking those barriers and accessing education. Not necessarily mathematics education, some education, BA history, BA literature, BA something else. But they miss it out. Because, and they would not, if they did that, they might actually become a clerk in a bank, or they would become something else. But that opportunity is denied to them because mathematics functions as a gatekeeper, something that we need to think about very seriously. Now, the thing is that this is nothing new. This is not true only in India. It's also true in other countries. And certain countries have actually acted proactively. So US, for example, so the minorities, the racial minorities there, and others also, other minorities also, religious minority and gender minority, other minorities have actually demanded that there be some change in the education system that actually takes care of the margins. So this lady, Claudia Zaslavsky, she was actually a teacher there in the US, and she had a lot of African American students. And so she thought, okay, she had the this thing right now, as madam said, we need to actually, what can we do? How to actually bring in something that actually students can appreciate. So she had to try and think of ways to bring in mathematics that actually makes African American students feel that it is actually part of their culture also. It is part of their, it's something that they can feel proud about. Otherwise they are only failing all the time in mathematics. Somehow mathematics is not available for us. They feel that, oh, mathematics is something that I cannot do. I can't do mathematics, right? So how do we actually bring in mathematics? So this is something that she goes to Africa for a couple of years. So she takes up a study, and then she finds wonderful things over there. So, and she says that she comes up with a book called Africa Counts, and the meaning of the word is so beautiful. Just give me 1 second. So the statement is really very interesting. Africa Counts is saying that Africa take note of Africa, right? It's not just like Africans know to count. Of course, they know to count. And Africans actually, there's good bit of work that's going on about the kind of mathematical knowledge. For example, there's somebody who has worked on the kind of the constructions that for which they have used fractals. Okay, Africans, whom we consider as absolutely not knowing anything.
Ma'am, excuse me.
Yeah.
Ma'am, your voice has become a bit soft. So
okay. I mean, I know why. Now it's okay. Is it okay?
Yes.
Okay. There's a mic there. Okay. So she actually worked with the community there and looked at the kind of mathematical knowledge that's embedded in the work there. You see. So she says that this book, Africa Counts, has a dedication to those Africans who are now engaged in in reclaiming their heritage. Scholars, including educators, must accept this challenge to continue the work of reclaiming the rich mathematical heritage of Africa. Right? That's what she says. And look at the kind of stuff that she's actually showing us. Look at this. These are some of their work. And there is mathematics in this. And there's mathematics in this. Look at the conical shape of the constructions. And then, I mean, this is just the beginning. She was one of the first people to actually begin to look at this. Now people have looked at, and I told you just now, some time back, that actually they even found that the constructions actually use fractal geometry. Okay. So this is one of the first beginning. This is a beginning actually to look at the kind of knowledge. Then there's somebody looked at. She also looked at other cultures. In Africa, not only So she found that they have this kind of this is what they have. Angolan sand drawings, they are called, like our kolam, na? This is exactly like our kolam, and men do it apparently. So look at something that's common between them and us. We didn't even know, and that's mathematical. So she was a teacher. I told you, so I probably kind of skip this so that I can save time. Then there's another person who actually looked at. So this person looked at another culture. So this person is Marcia Asher. Asher's husband, he was a mathematician. She had married an anthropologist. So, together they wanted to do something. They thought, okay, what can we do that is common to both of us? You are an anthropologist, I'm a mathematician. Can we do something together? So they went and looked at the community which actually had some mathematical knowledge. I'm missing the name. The Incas, mathematical. So she chanced upon this thing that you see in her hand. She's holding it like some torn skirt or something like that. It's not. It's actually a lot of threads with knots in some particular places. So this was actually, she finds this tool, and she's trying, all her time was spent in trying to understand what is this tool, what does it do? And she says that in the process, she understood their culture, and her husband actually, who's an anthropologist, began from the other end. She begins from mathematics end, and her husband begins from the other end, and they meet, and they actually try to understand. So this is a very sophisticated tool that the Incas had developed. And, they were all wiped out. Their culture, by 16th century, they were not there. I mean, there was no use of these kind of tools. I don't think that they are probably anymore in use, which if there had been anybody who could explain, she would have talked to them, right? This is like a calculator. It's not just it has a double thing. It stores numbers, and also it also enables you to do computations with it, right? So it's so she comes up with a book called The Code of Quipus, and she has, rest of her time she has actually looked at a lot of mathematics that they have done. So the next one. Okay. So she says that when she tried to understand the artifact Quipu, she did not know anything about the culture of Incas. The structural characteristics she came up with had resonance in other parts of culture. Being a mathematician, she had no preconceived notion about the culture of Incas to fit the artifact into it. Instead, she tried to understand their culture through her understanding of the artifact. The concluding chapter of the Code of Quipu, she broadens to say something like that. She calls it implicit mathematics, right? There is mathematics there, which is implicit. Looking at other things that they do also, implicit mathematics had come to believe that issues raised were not confined to the Incas. That is, there was a lot of what is not known that could be known about mathematical ideas in other cultures, and so she starts looking for substantial cases. And then the other, I think Angol and sand drawing, I told, she has a book. She's the first one to use the term ethnomathematics, basically meaning mathematics of people belonging to different cultures. That's the sense in which she uses the term ethnomathematics. So we have seen so far two giants. The third one, who is considered the father of ethnomathematics, Uviratan de Ambrosio. So Uviratan de Ambrosio actually also comes to look at the mathematics of other communities in a certain context. He is, along with other people, frontier researchers in areas such as architecture, religion, history, language, etc. And they were all looking at other traditions in mathematics, and he was other traditions in different in particular domains. The particular history as studied by other people, or history of other people, language, literature of other cultures which are not known, and he looked at mathematics, and then he comes up with with a lot of, he's quite, like Asher, like this lady Zaslavsky, he also actually sees that there is so much mathematics that's there, hidden and unseen by all of us. There's a lot of mathematics that is simply invisible to us. So he is considered the father of ethnomathematics because, unlike the other two, he just didn't leave it there. He has actually made a movement almost. So ethnomathematics, if today has a kind of a stature it has in the whole mathematics education community or outside that also, it's thanks to him, because he actually took it up as mathematics of other people which needs to be looked at. Okay. So the thing that's most important, I'll probably skip some of the slides. Okay, so this is important. I want to say this. Seen from the perspective of the discipline of mathematics as practiced in the universities, the forms of mathematical knowledge described above, including ethnomathematics, seem like primitive forms of mathematics. And Uviratan says that this is because the role of culture in knowledge construction has not been inquired into. This is the most important thing, that what is the role of culture and what do we understand as culture? So okay. Almost all cultures have had, basic things like counting and ordering, sorting, measuring, weighing, all these different ways in which they have done. So, and they have done it very differently and for different purposes. So, universality of mathematics for him cannot be sustained. Okay. Okay. So now what happens is that, see, I'm kind of moving fast. So, so let's kind of take a look at what we have done so far. One, we recognize that the university mathematics, what is called as pure mathematics, is of one kind, and even within the university there is another kind of mathematics, at least one another kind of mathematics, which we club all of them: engineers, physicists, accountants, everybody else we put in another basket, call them as non-pure mathematics. Right? At least we have got two, and that's not really two bags. There are actually bags within the bag. There's several bags within that bag, but we have these two classification. At least we know that there are two different kinds of mathematics. One is the mathematicians mathematics, and the other is the mathematics, university mathematics, which is not mathematicians mathematics, right? And then we looked at other practices which we probably think it's low level mathematics, etc., etc. Culture mathematics of the other people, other cultures, and so on and so forth. So by now, within the mathematics education community, the mathematics that mathematicians pursue in the universities is called academic mathematics. That's the disciplinary mathematics, and there are a whole lot of other mathematics. The university mathematics is formal. uses an axiomatic framework, and necessitates the use of deductive logic to prove or disprove mathematical statements. Now, what is ethnomathematics? This is very important. So, ethnomathematics is, according to Ubirathan, it is mathematics which is practiced among identifiable cultural groups. Who are they? Such as national and tribal societies, labor groups, children of certain age bracket, professional classes, and so on. He actually moves on from simply looking at culture as a community, referring to community, like tribal communities, this particular community, that particular Iravas, and somebody else and somebody else and somebody. No, he doesn't want to only restrict it that way. For him, culture is actually something that, say, mathematicians together, they form that's a cultural group, right? Physicists doing mathematics, they have a cultural, they're a cultural group. Why are they a cultural group? They're a cultural group because they have a common objective. They use a certain kind of a common language which they understand between each other. We do not understand most of what physicists say, and they have a purpose for creating a certain kind of mathematics, right? So the kind of mathematics that they need, they create. Mostly, they might actually look at mathematicians a bit, but we don't really share a language, right? Mathematicians have different objectives. They are pursuing truth, mathematical truths, and they are proving theorems, right? And then so these are also cultural groups. So according to Ubirathan D'Ambrosio, ethnomathematics is, the University of Mathematics is also ethnomathematics. The community of mathematicians share a common objective, beliefs and notions and symbols, and they can communicate with each other, understand each other, and produce a certain form of mathematics that makes sense to them, that they find useful for them. That meets some end. The rest of us are not at all unhappy, not knowing the mathematics that they know. So that's an ethnomathematics. University mathematics is one example of ethnomathematics, right? This actually breaks everything that you expected about mathematics, right? Princeton math department is one ethnomathematics group. You never thought, okay, you thought that, okay, now we'll have to go and tap into some tribal communities. Tribal communities mathematics is also ethnomathematics. The university mathematics is also an ethnomathematics. That is the major and interesting shift that Ubirathan D'Ambrosio brings into our understanding of ethnomathematics. That knowledge cannot be produced outside culture. Every knowledge, university knowledge, every knowledge is produced by a group of people sharing a cultural, cultural context. There's a certain cultural background to us. I mean, I may go from India, somebody else may come from Japan, somebody else may come from, but we all have something common as mathematicians. We all can communicate in ways that I cannot communicate with my sister, and you cannot communicate with your own family member. There's some communication that we share. So we are a cultural group. And I mean, so any anthropologist will actually agree to this definition of culture. Right? This bringing in of the role of culture in the production of mathematics. Like, why are we producing this mathematics? Right? Where did we start? Why are mathematicians interested in asking these useless questions like, can the equation x to the n plus y to the n is equal to z to the n have integer solutions? If it has, or if it does not have, what is going to change in this world? Are we going to solve the poverty problem? Are we going to stop wars? Are we going to do anything? Are we going to become millionaires? Are we going to become something? Are we going to find some solution for this particular virus that's actually killing us right now? Why are we interested in things? They say, forget, yeah, do whatever you like. I am interested in solving this question. And that's the end of it. I find beauty in that, right? It's not necessarily use. So this particular definition is very interesting. Ethnomathematics, it breaks it like that. Ethnomathematics. Now, what does it? This last term basically means techniques. Techniques stands for ways, arts, and techniques. Techniques that people use. Mathema for understanding, explaining, and learning. So he breaks this as ethnomathematics. This is techniques. This is understanding, explaining, and learning, and this is cultural groups, and that includes the cultural group, social group, so socio-cultural environment that is actually responsible for producing mathematics. So Princeton. So whenever you think about ethnomathematics, you think of the Tata Institute of Fundamental Research Math Department, think of Princeton, and also think of the various communities of vegetable vendors, weavers, and whoever else. So you must, that we must keep in mind. This is a challenge for us. So we, ethnomathematics, do we have ready-made solutions? We don't. We are very interesting. If everything is known, what's the fun? We have to do something, right? And one of the most interesting thing that they are saying is that, see, this is one of the most interesting thing that they've said. Ubi and Asher, Ubirat D'Ambrosio and Asher have a dialogue. There they talk about what people do. They say that, see, survival is, yes, we need mathematics for survival, but we also transcend that. You are tiling. You are just involved in this business of making tiles for the floor. Arey yaar, what is the objective of tiling? You just need a smooth surface on which you can walk. Why are you fussing about? Tiling is a very interesting problem. You really look at the kind of tiling, like symmetric tiling. I mean, all kinds of tiling. The Penrose tiling is a very well-known thing, So this tiling is actually becomes a mathematical problem. That becomes, first of all, an aesthetic thing. You find certain tile way of tiling appealing to you, and then it becomes a mathematical question. Right? This is totally unnecessary. Totally useless, unnecessary. You simply have to walk. But we are never satisfied only with utility. It's not that, I mean, your problem of hunger and shelter and clothing is solved, then you are peaceful. No, we all have a craving to transcend that. There are other things that fascinate us. These are actually basic things that we want to take care of, and sometimes even forgo that to be able to pursue something else, something transcend this immediate physical needs of ours, right? This transcending is something that we all, across cultures, across generations, have had this trait in us to transcend the immediate, right? So that's what he says. See, one of the major problems that Greek mathematicians had was, can we trisect a angle? That's one of the trisecting angle is a problem, serious problem. Can you use only a ruler and a compass and trisect an angle? You can bisect an angle very easily. Can you trisect this? That was a question that remained as a question. And you see, they would never actually physically do it. They have to do it logically. The thing is, Ubirathan says, if all that you wanted was to simply trisect an angle, you could have just somehow done it off. Physically, if you needed to actually trisect an angle, you would have done it off. But that's the immediate problem. That's not what you are bothered about. You are bothered about something else. You are bothered about the logical possibility of that. That actually transcends the immediate, right? Similarly, Asher talks about the tiling and so on and so forth. These are some of the cultural markers. These are the things. As a cultural group, we set up for ourselves certain things that we aspire for, certain things that we seek, that we all understand as a community, right? Some things that we understand, somebody else doesn't understand that. We need to do this. We have this as a practice. So culturally, as a cultural group, we actually share amongst each other something that we see as going beyond our immediate need. That what we find it as meaningful, right? I mean, for a economist or for a theater person, this equation x to the n plus y to the n is equal to z to the n, whether it has integer solutions or not. Let's say, I mean, some crackpot here, they kind of sit over this. My cousin actually went and killed himself because he couldn't solve the problem. They think that absolutely cracked lot, right? They don't see any meaning in that. But this person finds it so important that he finds his life worthless if he cannot solve it. I mean, I'm saying he here because most of the people who committed suicide are men. We didn't find women who actually committed suicide for such things. So the role of culture is central to this, and I hope, I mean, how many more slides do I have? So I'll come back to that slide a little bit later. I wanted to give some examples. So here, this is ikat weaving. Now, this is, I mean, the picture is a bit hazy, but this weaving is a very, this very specialized kind of weaving. It has the same pattern both sides. The weaving is, and this has been done across the world, apparently, in different parts. In Tamil Nadu, you have this, in Tamil Nadu, I'm saying, in India, you have it in Bhubaneswar. In Orissa, you have some group which does that. In Andhra Pradesh, Pochampalli, they do this. And it's a very complicated kind of work. It is not like any other weaving. I mean, any other weaving also calls for talent and some mathematical knowledge, certain way in which they set it up. Handloom is that way, a place where you can look for. And then I was looking at this. This course, there's a lot of mathematics that should go into this, in designing, shaping these things. in every, from getting the leather to work on, ready to work on, and actually to make these designs on it, and so on and so forth. Somebody should study them. Now, how do they, what, most of the time they are not using any mathematics to do that they learned in school to do this. They are using mathematics that's coming from within. Okay. Is there any other picture that I wanted to show? Okay, so let me go back. Right, I showed some pictures. There are several others. There's boat builders, for example. There's this person who Swapna Mukhopadhyaya, who has done some work with, she's an anthropologist who works in math education. She's in the US, Portland. She has actually worked with she's a Bengali, right? And so she has worked with the boat builders, and she's tried to understand the kind of mathematics that these people who have completely no education, what kind of, I mean, those boats shouldn't sink, right? They have to go, right? So there is a kind of mathematics that they know. So she's been working with them to try to decode the kind of mathematics that they have. Now, the thing is that, yeah, okay, so I have given some examples of ethnomathematics. I have said what is ethnomathematics, and then the major challenge for us is that what is the use of it and what is not ethnomathematics. In fact, I want to say that I had put a slide. 1 second, I'll go to that slide. Okay, where is that slide? Barters I'll come to, because before the barter, I should actually say what is not ethnomathematics. So simply trying to fit cultural practices of certain groups engaged in some work into the existing school mathematics curriculum is not ethnomathematics. It is not like taking examples from somebody else's. Okay, right, okay, so you have some design there in your dress, so we'll try and put that in. No, that is not. You have to, ethnomathematics has to be, you have to take it along with the culture. The cultural objectives for which it has been set up together. So mathematics does not, it's not simply numbers hanging in the air. Numbers actually are existing in a certain cultural space. You have to actually bring it in. The culture actually determines how to actually do this mathematics. And you have to bring that along into the school curriculum. And how do we do that? If you simply keep your mathematics and it's just like putting old wine in a new bottle. No, that's not what one actually, if we do that, then we should not say that we are doing ethnomathematics. We are doing our mathematics, we are simply packaging it slightly in somebody else's container. That's not ethnomathematics. If we want to really do ethnomathematics, and that's why I said that this project is not a very easy thing. We really need to invest in this. First of all, we need to really go work with communities, understand the different communities, including the mathematics community, work with and understand the kind of mathematical knowledge that they have, because that will be completely embedded in the work that they are doing. We have to work with them to uncover it in the way in which they understand it, and then bring it into the school. Now you might say, who is interested in this? The thing is, living traditions. Aldo Parra, whose name I mentioned, who is a very young mathematician in a Latin American country, he is actually, he talks about, he says that, countries like India, countries like theirs, where there's a huge rural population, where people are still engaged in the kind of boat builders and the others who are engaged in work which within the local market, rural Indian market, has value, they are actually using some mathematics, right? Or even for the urban consumers, when weavers and the other people who are making things that we consume, which are cultural things that we use, they also are using mathematics. So there is a context for their children to feel happy that, and in fact they might do very well also, because they have understood that mathematics by being part of that whole community, and they might actually excel in mathematics, and they might learn something which will be useful for them in their future if they actually want to do that work. So that kind of mathematics also should figure in school. And Para actually says that this you should do it by bringing them, the so-called illiterate weaver, illiterate mason, illiterate whoever else, and you, the scholarly mathematician, should come together, work together, and design a curriculum in which things actually are bartered. He says that barter, you give some and they give some, and then together create this new hybrid mathematics, which is actually our need. which is the kind of thing that we might actually use. And then there is hybridization constantly. Ethnomathematics, Ubiratan says, is not staying the same. It's not like the weaver of today did exactly the same thing that their, 300 years back their ancestors did. No, they are doing for the time in which they are living. So there's constant hybridization, there's constant change. Ethnomathematics is something that keeps changing. Okay, so I have said a lot, and I mean I was warned that I shouldn't just go on talking, but then I somehow couldn't kind of give you some work in between. But so I should therefore stop here and take questions from you and try to have a discussion. I mean, I'm probably skipping. I mean, I've said more or less everything that I wanted to say. Yeah. So it's, I mean, how much time do we have? Yeah, I have more or less, I have half an hour. Yeah. Yeah.
Actually, yeah, the time is up and we can take some questions. So I request Daya and Nisha, if there are any questions, can you just speak up?
Thank you, ma'am. Thank you for giving an opportunity to attend this seminar and all. Actually, I am teaching grade 5 in Abu Dhabi. And actually, I like your talk, ma'am, and I feel that the same thing what you tell is right. For as if I am going to my class, they feel that mathematics or maths teacher is coming. That is the attitude. It is created by the community itself. But I want a suggestion from you. Like, if a child is so irritated with math, how can we improve as a teacher, as a community? If I want to, now I am also working as a coordinator of math itself in my school. So how can we make that change to way of thinking?
I mean, teachers really are not really so very well positioned to do too many things because they are constrained by the curriculum that is designed, syllabus and the exams. These are the things that regulate a teacher's work in the classroom. Though she might be extremely concerned, as you are, about a few students who are really terrified. And I think there's also pressure on them to worry about these students because but then teacher is, I mean, it cannot, unless she's given some, I would first say that the teacher should have some freedom to design the curriculum for the class that she's teaching. That's one of the most important thing that we should trust the teacher and give her the freedom to design something that works for her in the classroom. Autonomy of the teacher has to be respected. Only then this can be done. And then the teacher might experiment with many things. For example, she might actually also take to the classroom something that gives a very positive experience of mathematics for this child. You might explore, try and see what works for the child. Right? We do not, I mean, I don't want to fool ourselves by saying that, we have ethnomathematical tools. I mean, like, the thing is that this particular child comes from a certain cultural background. There is probably some kind of a mathematical knowledge that the community has, which he might be familiar with or she might be familiar with. We may not really be able to tap that very easily. I mean, that's not the job of a teacher. That's the job of a researcher. Researchers will have to work on that, and that the state has to fund them. But as a teacher, faced with an odd situation, if you had autonomy, if you are not constrained by exams and syllabus and etc., you might actually try and explore like what other, I mean, I think that like when I tried algorithms are very difficult for children, right? Division algorithm, such a difficult thing for most of the children. Let me, we used an alternate algorithm in the classroom. I do not know, you all might know this. I'm going to exit the screen, and so that, or I might probably try and use it here, right here, right in the last slide maybe. Yeah, so I can try and write here. Oh, I should exit the full. Yeah. I don't know whether I can write. Okay, so let me get a Word document and I can write on that. Okay, I'll open a Word document and probably I can write on that. So, if we teach division, for example, differently, rather than giving the algorithm right away, even addition algorithm, that's what Teresina Nunes says. I mean, like, allow children to do addition on their own. You don't teach them how to add. They will figure out how to add. You actually help them understand what they are doing rather than telling them how to do. Where is Right. I have to share screen. Share screen. Yeah. So the division algorithm that we used was something like this. This is, I think, there in the NCERT book. Most people have not used that, but then if one uses the NCERT book, one can find division which is really interesting to do. So for example, supposing you want to do, say, 247 divided by 9 or something like this, right? So we do the algorithm thing. No? Children get confused, like, okay, you have to put a 0, you don't know where to put a 0. So instead you could actually take this alternate algorithm. 247 you can take, you have to divide this by 9. So what is that? What is the number of how many times, say for example, you could actually take, say supposing you give 10, you have 247 rupees and you have to give 9 people. So first you give everybody, say, 10 rupees. How much would you spend? 90. This is whole number, right? Then you do the subtraction, then try and see how much more can you give, and go on doing it, and then actually add up this. This method, when we used in the classroom, children actually felt division was meaningful. This whole method of it just goes against everything that they have learned. You commit a mistake, they forgot the tables at some point, so they will not be able to use it. They commit all kinds of mistake with this method doesn't work. This works much better, so try and use an alternate algorithm. Similarly, addition, small children find that, in class 1 you told me to add 8 and 7. I was in class 1, you told me to add this and asked me to put this. Now I'm doing the same thing and you are saying it's wrong. Now suddenly you are saying don't put the 1 here, put the 1 here. I don't understand mathematics. Very scary. No, algorithms are extremely difficult for children. On the other hand, if you allow them to add 18 and 17 meaningfully, like, 18 becomes, if you add 2 more, it becomes 20. So take 2 from there, put it here, it becomes 20. How much is left? 15. So it is 35. That makes sense for them. Now, these are some of the, so this is some examples I'm giving, but then, one has to look around for material. But the good thing today is that Google Scholar is a place from where you can actually access a lot of material. You just have to go to Google Scholar and you have lot of literature at your fingertip today, teachers' experiences or alternate curriculum, all that is available. So you could try and see what, experiment with some things that might be useful for you. I don't know whether that answer was of any help for you.
Yes, ma'am. Yes, ma'am. It's fine.
Okay.
Yeah,
But
so
I mean, also reach out to people like us. If we have something, we will share with you. Yeah.
So we have to just move ahead now, ma'am, because the time is up. And shall we close the session if there is no other question? Daya and
I mean, if there's
Nisha,
any other question, I'll answer. Otherwise,
Ma'am, there are some questions.
Okay.
Yeah, please tell.
There is a question from Deepak Vasishtha. Don't you feel mathematical education should be a part of school curriculum? What we are teaching in classroom is algorithms of mathematics most of the time.
Absolutely right. I totally agree with you. Absolutely. That's true. That's the problem. We don't really, that's why mathematics becomes so very scary for children. Right? We teach them algorithms all the time. We do not teach them mathematics. Mathematics will call for time. You need to give them some time because everybody doesn't comprehend concepts the same way. Sometimes it occurs to somebody on some days. You still have to give them more opportunity. So yeah, sure, absolutely. I agree.
Okay, ma'am. And the next question is, the CBSE board is now making an art integration as an important part of the curriculum. Can you give us some links where we can read up about ethnomathematics, mainly for the primary section?
Okay. Yeah, see, links, I wouldn't, I mean, what I can do is I can send you a list of references maybe. But my suggestion is that if you're asking for links, that means you already have access to net. So I would say Google, go to, I'll just 1 second, give me. Google, go to Google Scholar and ask for ethnomathematics, and then you get a lot of stuff. That is one way of doing it. Share screen. Yeah. So go to Google Scholar. Google Scholar and say ethnomathematics in the classroom or something like that, you will get a lot of some examples. Ethnomathematics, one should know, is an emerging domain. It is not really already well known. It's not that we already know a lot of it in the world. In some places, in some of the Latin American countries and in Australia, there are some groups which have actually worked and have evolved. With Maori tribes, somebody has done something. So you can say ethnomathematics for primary children, school children. Okay, you might actually find something. So yeah, you can try and see if something will work. There are some people who have raised a lot of serious issues with ethnomathematics, but there might be some primary school education here. No, there's something here. So you have to search for it. I mean, if you want, I can search and send you something, but they will all be research papers, So actual curriculum that people have used in the classroom, one should actually make the effort to reach out and try and get. We can try and do that. I do not have right away something to give you, but can try and get something for you if you want to kind of try it out in the classroom. Yeah.
Ma'am, the next question is it equivalent to mental math?
No, not at all. Mental maths is also a kind of ethnomathematics because you are learning it from the community, from your, as a group of people, you learn it. But all of ethnomathematics certainly is not only this, mental math, no. There are a lot of other things, designs. I mean, for the tiling, for example, the constructions, for example. Carpenters mathematics. Carpenters actually share a certain way of cutting wood. Tailors. They are actually dealing with space, geometry. There's a geometry that they do. There's one paper that I have actually talked about, which is actually looking at Islamic architecture. There's so much geometry there. So yeah, these are not only about mental math, na? There are so many other things, like Kolam, I said. So we need to really, I think that we really need to actually spend more time to try and understand more about the value of ethnomathematics and how to bring it in. That to that extent, we need to actually say that we will keep our mathematics aside for a while, try to look at mathematics from their perspective, mathematics itself from their perspective. If you try to do that, then you are doing ethnomathematics. Yeah. So there is a lot of scope for doing some very good work. There are a lot of people in India who have the potential to do it. We need sustained support from the state to do something really meaningful. Vedic mathematics, ethnomathematics. There is nothing like Vedic mathematics. There is nothing like Vedic mathematics. There is a lot of mathematics that is Indian mathematics. I asked you to ask me this question. Indian tradition in mathematics is very different from the Greek tradition in mathematics. If you look at two civilizations which are ancient, Indian tradition in mathematics is also an ancient tradition. Theirs is also ancient, but they're fundamentally very different. Indian mathematics was not axiomatic. So there is this person, Saraswati Amma, who has looked at geometry in India. And she says that Indians simply did not do geometry beginning with axioms, whereas the Greeks did. So these are two different, epistemologically different objects, two different schools of thought. So that is Indian history of mathematics. So you must look at that. You might probably try and bring that, but that's also high. There are also mathematics that is living traditions now. That's almost dead. The Indian tradition in mathematics is dead, actually. Please don't take, I'm not saying happily this, but it is dead because there is nobody from whom you could actually do the way the Indians did mathematics then. The whole approach is not there. It's gone. No university, you can't get into a university. Other traditions, Ayurvedic tradition is still there, right? Indian knowledge of medicines is still there. But Indian mathematics, we only have records. We do not have people who do it. We don't have. It's gone. So there are some very interesting people who looked at Indian history, history of mathematics in India. Saraswati Amma is one. She looked at geometry. There are other people. Aved Singh Narayan and yeah, I have a lot of books. Then there's this lady whose book is really very well respected. I need to get the names. Yeah, I'm sorry.
Devi.
No. Shakuntala Devi is better than your calculator and a computer. You know, she had a kind of way with numbers. She's not really done that way mathematics. She works with algorithms. No, the person who has looked at the history of mathematics in India is this lady. What's her name? I'm not getting the name immediately. Kim Flofker. That's the name of the person. She's written very good book. Then there's this other person, Joseph Gevorgis. He came here. He works in the he's now very old, but then he has written this very beautiful book called The Crest of Peacock, Non-European Roots of Mathematics, looking at diverse traditions in mathematics. You know, very many different cultures. The whole thing about Inca mathematics is that, you know, they had a different tradition that is dead and gone. Wiped out. Indian tradition is gone, actually. I mean, you know, anybody who actually is honest would admit that Indian achievement in mathematics, in fact, George's claim was that we had done mathematics which actually was a precursor to calculus. That's his claim. I don't know if there is sufficient evidence for it, but he makes that claim that the Kerala School of Mathematics, already there was good bit of mathematics that was developed that could be seen as the precursor to calculus. That was our kind of achievement in mathematics. But the approach was different and it is displaced. It's not there anymore. Nobody does Indian mathematics anymore in the world. That's a bit sad. Yeah.
Yes, Nisha, any more questions?
No, ma'am.
Yeah. Okay, so ma'am, yeah, thank you very much for your session. I think we have appreciated this topic so much. It was a new topic for us and we wanted to know more about this topic. You have motivated us to learn about this topic, and I think we appreciated our own culture also through this talk. So I would now request, ma'am, I will just, we as a mathematics pedagogy group, we always do a small study. So I will request Alsona and Rachel to present that study.
Oh, sure.
Just a brief one, ma'am. So they'll just present.
Yeah, that'd be nice.
Jayasree ma'am, can you stop sharing? So I will share.
Yeah, I'll do that. Yes. Sorry. Yeah, right. I've stopped. Yeah.
So good evening, everyone. We as Maths Pedagogy Group, we had done a survey about mathematics literacy. So now I would like to present the stats of the survey that we have received. So as we know, what is mathematics literacy, also known as numeracy? It means having the ability to problem solve, reason, and analyze information. It also means the ability to understand the language of maths. So the first question that we had, lack of knowledge of mathematical language can hinder the development of mathematical concepts. And the total 87 people had responded to this survey. So as we can see, 62 people, that is around 71% of respondents strongly agree to it, whereas 23 respondents agree to it, whereas there are 1 respondents each for neutral and disagree. The next question is, the formulas depicting the relationships between terms and concepts is difficult for student understanding, and as we can see, 46 respondents have agreed, whereas 12 of them have strongly agreed, and we have 17 and 11 each for neutral and disagree, and there is 1 respondent who strongly disagrees to this. The next question. Schools must focus on mathematics articulation skills by teaching mathematics language. And as we can see, 85 respondents, that is almost 98% of respondents feel that yes, schools must focus on mathematics articulation skills by teaching mathematics language. Next question. The synonyms used in mathematics, for example, altitude and height, could create conceptual conflicts in the students. And the stats for this answer is 61 respondents feel yes, whereas 26 respondents feel no. Next question. The meanings conveyed by the word problems are difficult to comprehend. And we can see that 69 respondents feel that sometimes, yes, the meanings conveyed are difficult to comprehend. 6 respondents feel always, whereas 8 feel often, and 4 respondents say that no, never. Next question. The special symbols created for mathematical communication needs special attention by teachers and students. And we can see that 45 and 37 respondents strongly agree and agree, whereas 4 of them have a neutral opinion and one disagrees with this statement. Now I would request Rachel to continue with the further questions.
Thank you, Alsuna. The 7th question is, mathematical phrases if and only if greater than is equal to create confusion in child's mind. So here, out of the 87 respondents, 7 respondents have responded as always, 53 participants have responded as sometimes, 21 participants has responded as often. Also, I can't see the screen. Can you minimize it a bit? I mean, it's not fitting. Yeah, thank you. And 6 participants have responded as a never. So as you can see, more than 70% of the total participants feel mathematical phrases if and only if, greater than, is equal to, etc. create confusion in the child's mind. The 8th question is, also the 8th question. Thank you very much. The 8th question is, the conversion of mathematical problems into a visual representation is a difficult task for the child. Here, out of the 87 respondents, 13 participants strongly agree, 46 participants agree, 14 participants have a neutral point, and 10 participants disagree, whereas 4 participants strongly disagree. So as you can see, more than 60% of the total participants believe that the conversion of mathematical problems into a visual representation is a difficult task for the child. The 9th question is, teachers must vocalize mathematical formulas in order to help students master them. So here, 72 participants has responded as in yes, whereas 15 participants have responded a no. So as you can see, more than 80% of the total participants strongly encourages teacher to vocalize mathematical formulas in order to help students master them. The 10th question is, all teachers focus on the positioning of mathematical terms and concepts. For example, RHS, LHS, for adequate understanding of the steps of problem solving. So here, out of the 87 participants, 26 participants strongly agree, 47 participants agree, 13 participants have a neutral point, whereas no participants disagree, and 1 participant strongly disagree. So as you can see here, more than 80% of the total participants encourages teachers to focus on the positioning of mathematical terms and concept for adequate understanding of the steps of problem solving. The 11th question is, teachers must encourage mathematical discussions and conversations to develop mathematical fluency. Here, 80 participants has responded the answer as in yes, whereas 7 participants says no. So here, as you can see, out of the total participants, 90 participants firmly believe that teachers must encourage mathematical discussions and conversations to develop mathematical fluency. The 12th question is, reading, writing, and word meaning must be taught in mathematics just like language teaching. So here, out of the 87 participants, 33 participants strongly agree, 35 participants agree, 11 participants have a neutral viewpoint, 7 participants disagree, and 1 participant strongly disagree. So here, as you can see, more than 75% of total participants have suggested that reading, writing, and word meaning must be taught in mathematics just like language teaching. The last and the 13th, that is the 13th question is, the mastery of mathematics vocabulary is a strong indicator of a student's success. Please share your valuable thoughts here. So here, all of the 87 participants have agreed to the above statements and provided their valuable feedback. They say, most of the students learn mathematics without understanding it. Therefore, there is a need of understanding mathematics and mathematics vocabulary. It simply depicts that child can have a greater grip on the subject matter. This will enable students to enjoy mathematics, taking initiative to solve problem by themselves, and of course, help them gain better understanding. Students can also be encouraged to undergo individual research in mathematics and correlate mathematics to everyday life. Hence, it's rightly said that the mastery of mathematics vocabulary is a stronger indicator of a student's success.
It's very good. Interesting survey.
Thank you, ma'am.
Thank you. Thank you, Alsona and Rachel, for presenting that study. So we come to the end of this session. And before ending the session, I would like to place my sincere thanks to the student coordinators. We have Rizal, who introduced the speaker, and we had for the question answer, we had Daya and Nisha. We had the study which was presented by Alsona and Rachel. We had, now we will be having Clarice, who will be proposing the vote of thanks. And we had Alsona and Rizal as the co-host for today's session. So students, thank you very much. And I would request Clarice to propose the formal vote of thanks.
Yes, ma'am. Before I start the vote of thanks, I would request all the participants that the link is already been posted in the chat box. So you all can fill the feedback form. Good evening, everyone. So it is my privilege to propose a vote of thanks for the S.X.I.E Maths Webinar Series 6 2020. So on behalf of Manager Father Blaise D'Souza, Principal Dr. Susama Samuel, Staff in charge Dr. Winnie Sebastian, I extend a hearty vote of thanks to our speaker, Dr. Jayasree Subramaniam, who spared time from her busiest schedule for this webinar. Today, we have been privileged and had this amazing opportunity to hear your session on ethnomathematics. I am sure that all this information will help us immensely in our respective fields. So thank you once again, ma'am. Next, I would like to thank our manager, Father Blaise D'Souza, Principal Dr. Susama Samuel, for allowing us to continue with our mathematics webinar series 6 and for all the other webinars that we conducted throughout this year. I would like to thank and appreciate our staff in charge of Mathematics Pedagogy Unit, Dr. Winnie Sebastian, for motivating and encouraging us to continue with this webinar series. My heartfelt gratitude to our student coordinators, Alsona, Rizal, Rachel, Daya, Nisha, and Clarice, for being a strong team behind and providing technical support. And last but not the least, a big thank you to all you participants for your presence. Without each and every one of you on Zoom as well as on YouTube, this event would have been successful. We would hope that you take back something from today's session. So once again, thank you for making this event a success with your enthusiastic participation. With this, I end my vote of thanks. Now there are some instructions regarding the feedback form. So the link is already been posted on the Zoom chat as well as the YouTube chat. So please note that later no link will be posted on the WhatsApp chats. Feedback form link will be open up till 7:30. So while filling the feedback form, make sure that you'll enter the correct email address. If you do not get the certificate, wait for some time or check your spam folder. Even if then you do not get, then you can contact any one of the student coordinators before 7:30. Thank you. Now over to Vinny ma'am.
So Jayasree ma'am, thank you very much again for sparing your time, and there is a lot of appreciation for you on the YouTube. They have really enjoyed the session. It was interesting and it was informative, and they are going to use it further in their teaching, and it has widened their knowledge. So I am just transferring all the appreciation to you from the YouTube as well as the chat. You can also see that. But it has really been a very good session, ma'am. Very interesting, very informative, and I think it is really enriching for us. So thank you for coming for this webinar and accepting our invitation. Thank you very much, ma'am. Ma'am, Dr. Susama, ma'am, would you like to say something, or we can conclude this, ma'am?
I have sent my congratulations note. Yeah, I think so. And it was a great session, very informative session. Ma'am, Jayasree ma'am. Yeah,
I really hope that it was of use, because I really didn't give time in between. I forgot that. Probably it was a very continuous, boring session. Maybe I thought that it might have been a bit boring for the participants.
It was great.
It was okay. Thank you so much. It is a wonderful initiative. I mean, really appreciate the college, and you've done your homework for it, and you're doing extra. I mean, this is really remarkable. I appreciate you really very much. This is quite nice. I really am happy.
Thank you, ma'am. Thank you.
Thank you, ma'am.
This opportunity was really great. Thank you so much.
Thank you, ma'am.
Yeah.
So I request the participants to kindly fill the feedback form before I log out from this meeting.
And you have a lovely thing in the wall there, which is a lot of ethnomathematics there.
Yeah. Hardly.
Yeah, hardly painting. Yes. Yeah. Okay then.
Okay.
Yes.
Okay. Thank you. Bye. Yeah.
Bye, ma'am.
Bye. I'm leaving the meeting.
Yes. Thank you.
Yeah.
Thank you, Vinny. Bye.
Yes. Bye, ma'am.
Bye. I will leave.
Yes, ma'am. Thank you. Father Blaze could not join. He said he had some work.
Okay.
Risal, can you hear me, Risal?
Yes, ma'am.
Can I end the meeting, or should I wait?
Ma'am, just wait for 2 minutes. Like 1 minute also is enough.
I'm just pasting the feedback form in case.
Yeah. Ma'am, for one last time, paste it on YouTube also.
Okay. Risal, can I end the meeting?
Yes, ma'am. Yes. Thank you, ma'am.
Yeah, welcome. Bye. Bye, everyone.
Bye.
It's okay, no, that YouTube will go on, no, Risal?
Yes, ma'am. Yeah.
If I end, there is no problem, no, now?
No, ma'am. It was posted earlier, no? So I hope all must have filled by now.
Okay.